Hello, Airbus Cockpit Coach here, and welcome to the channel. In this video, we're going to explore the APU, or Auxiliary Power Unit, in a bit more detail, understanding what it is and how and when we use it. So, what exactly is the APU? The APU is a small gas turbine jet engine which is located in the rear of the aircraft and supplies electrical and pneumatic power to the aircraft. So on the ground, it supplies electrical power for the aircraft and provides bleed air to start the engines and supply the air conditioning system. Generally, we turn the APU on just prior to pushback, and then it's turned off from engine start until after landing, and we turn it back on our taxi in prior to engine shutdown. However, it can be used in flight as a backup generator or to gain increased aircraft performance. So with the APU off, bleed air will be taken from the engines to supply the air conditioning system. That reduces engine performance. With the APU on, the air conditioning system is supplied from the APU, and therefore we get greater performance from the engines. So, as an example, if you're at a high altitude airport where the air is less dense, we need more performance out of the engines. That's an example of where we'd take off with the APU on. Also, if you have to achieve a very high climb gradient, again, we need more thrust from the engines, and in that circumstance, we can also leave the APU on. The APU BLEED system is fully automatic, and the APU speed is always set to 100%. It has, however, a maximum limit of 107% on the M1. The bleed air from the APU cannot be used for wing anti-ice due to there being no temperature regulation of the APU bleed air. So bleed air from the APU going into the wings could potentially damage the slats, so it's not used for that purpose. We can start the APU via the onboard aircraft batteries, the DC system. So here's our APU panel on the overhead. When we press the master switch here, electrical power goes to the APU, which then performs a power up test. The air intake flap then opens, ready for the start sequence. We need to wait at least 3 seconds between pressing the master and the start switch for the self-test to be completed and for the flap to open. And then we can press the start switch. And when the start switch is pressed, the starter is energized and ignition turns on. Once above 95%, the APU can supply bleed air and electrical power. And we can see our APU information here on the lower ECAM. You'll see once it's turned on, you'll see a rise in EGT, which will jump up initially and then fall back down and settle as it's doing now. That's normal. And you see our M1, as soon as it gets to 95%, we get electrical power available there. To shut down the APU, we simply press the master switch again. And when shutting down, the APU will run for a cooling period of 60 to 120 seconds if the bleed air was used. On the ground, the APU is capable of an auto shutdown procedure, which will trigger if an APU fire is detected, and that's on the ground only will the automatic shutdown occur. Or alternatively, if the APU fire button is pressed up here, and of course it will shut down if the master switch is pressed. Before we start the APU, we will have wanted to have conducted our pre-flight, which will include the APU fire test. So we'll press this and make sure we've got the relevant indications showing here. And also the external walk-around should have been completed as well. On the external walk-around, part of the check there is looking at this little dot here, which is hard to see in this livery. But there should be a red indication inside that small dot there below the APU. And that indicates that the fire bottle is in a serviceable condition for the APU. If it's black, we cannot start the APU and we need to get maintenance out. So we need to conduct that check first. It's worth noting that if starting the APU off the DC supply or the onboard batteries, that does have a strong discharging effect on the batteries, and you're not going to get too many attempts at that. And it's also important to know that after 3 failed start attempts, we must wait an hour before another attempt at starting the APU, and we're most likely to get engineering out to take a look at it if that occurred. In terms of the overall limitations of the APU, The maximum altitude the APU can be used to assist an engine start is 20,000 feet. The maximum altitude for providing air conditioning and pressurization to a single pack is 22,500 feet. The maximum altitude for providing air conditioning and pressurization of both packs is 15,000 feet. The APU itself has an operational and restart ceiling of 39,000 feet, which is the aircraft's limit, and can also provide electrical power anywhere up to 39,000 feet. APU usage is pretty restricted. The majority of major airports now have restrictions on when we can use the APU due to the noise and also the emissions they create. So generally, if we have ground power available, we would delay the use of the APU unless we have very hot or very cold conditions and we need to get that cabin comfortable. We can't have people freezing or overheating. So in extreme circumstances, we will turn the APU on. Other than that, we obviously want to conserve fuel. So if we have ground power available to us, we'll be delaying that as far as we possibly can before engine start, and we'll generally be looking to start turning the APU on once we've received the final load sheet and we're fully loaded and ready to begin pushback. It is often the case in the real world, however, that ground power supplies are unserviceable, take time to arrive, or the people to plug them into the aircraft aren't always waiting for us. There are other occasions and factors in the real world which we have to deal with. Thankfully though, in the sim, we usually always have ground power available to us. If we come to the fuel page now, we can see that the APU draws fuel from the left wing tank. So if we are using the APU for prolonged periods, we need to monitor the imbalance of fuel. When power is provided by the APU, and we have the veil here indicating that, we do not need to make any changes in terms of switchover in this aircraft. That is done automatically, and that's configured to a predetermined logic. Now we also have the APU bleed switch here, and that essentially turns on the high pressure air for the air conditioning system and also makes it available for engine start. So it turns the engines on start. So to perform an engine start, we want that to be turned on, and obviously to feed the packs and cool down the cabin or regulate the temperature in the cabin and provide airflow, we need the APU bleed to be on. When starting the APU, we generally want to start the timer using the chrono button here, which displays the timer on the navigation display. And the reason for that is the APU is associated with what's known as fume events, so drawing in emissions into the cabin. Now the reason why that occurs is there's sometimes unburnt fuel and oil in the APU, and we want that to be burnt off before we turn on the supply of air. So depending on your standard operating procedures for your particular operator, the time between turning the APU on and turning the bleed air on does vary. Some airlines are 2 minutes, some airlines are 1 minute. Personally, I leave it for 3 minutes in the real world, just to be sure. And that's something I've noticed as sort of being an optimum time. But although my standard operating procedures are a little bit less than that, I tend to just stick with 3 minutes, and that works well in terms of not bringing fumes into the cabin environment. So once your 3 minutes has elapsed, we can turn on the APU bleed up here, and that will then start supplying air to the cabin and also make it available for engine start when we select ignition start. When we select ignition start down here, the pneumatic air supply automatically switches to the engines for engine start. After a landing, we start to consider turning the APU on again, and we want it on before we turn the engines off on a stand. So depending on your length of taxi, will determine when you turn the APU on. It generally takes a minute to start, so it's a bit of trial and error in terms of judging where to turn it on the taxi in, but we do need it on before shutting the aircraft down, so the APU can initially pick the power to the aircraft up before the ground handlers plug the external power supply in. There's also another reason for that as well, and that is the possibility of there being a tailpipe fire. On shutdown, it's possible for some unburnt fuel to remain in the engine, which can ignite and cause a tailpipe fire. As part of the procedures to deal with that, we need to crank the engine, which involves blowing bleed air through the engine to get rid of that residual fuel. If the APU is not available, we will not have bleed air available straight away to conduct that checklist. So that's another reason why we want the APU on before shutdown. So once we understand we have ground power connected, we can turn the APU off. It starts to run down. We cannot power down the aircraft until the flap has closed. So we need to wait for this flap open message here to disappear before we power down the aircraft. That's important to remember. So that's an overview of the APU. I hope you found that useful. If you have any questions at all on that, please drop them into the comments box below and I'll do my best to answer those. And don't forget to hit like and subscribe to stay up to date with the latest content. I'll catch you on the next one. Thanks for watching.